Okay, so we are going to start with 9.2, which is the sum and difference formulas. Now, I'd say that this is more important than the 9.1. No, actually, I say that 9.1 is more important than this, but you still need to know this because you want to calculate the angles. If you want to calculate the angles of 15 degrees, 37.5 degrees, you will need to know what this is, or 3 degrees even. So, let's get started. We have our sum and difference formulas right here, which we have to figure out, and our difference formula is basically what we're trying to find is a cosine of a minus b. And from these graphs, I've basically already written out everything you need to derive it from to derive from these graphs. So if you have these two unit circles right here, they're not R circles, they're unit circles. So they're unit circles of 1, and therefore we can use that Pythagorean identity, which says sine squared plus cosine squared is equal to 1. So basically I drew this, we have cosine squared plus sine squared, that's equal to 1, and cosine squared plus sine squared, that's also equal to 1. And so what I'm trying to get to you, and what I'm trying to get you to know is this is the exact same triangle as this. This is the exact same triangle as this. And the reason the reason they're the exact same triangle is if you subtract B angle, so this is B, this is angle B, right? And then this is angle B minus A minus B. So if you subtract B angle, you'll get 0, and then this will still stay as A minus B. Therefore, the angle at here will be 1, 0, as in sine 0 is 0 and cosine 0 is 1, and this is cosine A minus B and sine A minus B. So that's how we get this triangle is congruent to this triangle. So we also get this equation is equal to 1. Now we're gonna notice something a little bit hard to notice at first, but basically we're gonna do some multiplication. We're gonna multiply. Well, we're gonna try to find a way to get this cosine A minus B alone. And to do that, we don't have to do any of this algebra stuff. We can just look at the graph and we'll know why that's the case. So we can take this, multiply by the 1, right? We can multiply the x-coordinate of the points, cosine A minus B multiplied by 1. So cosine A minus B multiplied by 1 plus sine A minus B multiplied by 0. And that should exactly be equal to cosine A cosine B plus sine A sine B. And why is it equal to cosine A cosine B sine A sine B? The reason why it's equal is they're both equal to 1. That's why, right? Everything is on the unit circle. So every expression that I have right here, every one of these relationships is equal to 1. So anything that I put on the unit circle, their lengths will be equal to 1, and therefore you can use this point kind of thing that you wouldn't normally get to use. So in this, it will be cosine A minus B times 1, which means it's just the cosine A minus B, right? Just this. And then sine A minus B times 0, so that doesn't count. And this is our remaining expression. So therefore, we have cosine A minus B is equal to cosine A cosine B plus sine A sine B. And that is our first identity derived. That's an ugly rectangle right there. There you go. So what about cosine A minus B? Right? Those of you who are focusing, you should probably notice that this is also equal to cosine A plus B. So we're just going to use that same formula that we just derived a few seconds ago. We'll have cosine A, cosine minus B, plus sine A, sine minus B. And what will this give you? This will give you cosine A, cosine minus B. Cosine of a minus, if you looked at the previous lesson, the cosine of a minus is just the cosine of that same thing. So it'll just be cosine of B, cosine A, cosine B, and then added to sine of a minus will bring the negative in front. So it'll be plus sine A minus sine B times negative sine B, and therefore it will be minus sine A sine B. Now what about sine? Sine is a little bit, sine's a lot harder actually. Sine's a little bit harder. Sine's a lot harder. You could say both things, but the reason why it's a lot harder is because if you go back to this unit circle, sine is automatically paired with the multiplication of 0. You can't have sine multiplied by 1. However, we can try to manipulate this function right here. We can add something to each one of these. Okay, I'm gonna erase everything here. We can add something to each one of them in order to make the cosine function turn into the sine function. And I've already derived it previously. Now we want to find sine A minus B. And this is exactly equal to cosine of pi over 2 minus whatever I want to find. Right, this is pi over 2 minus A minus B. So this function, so everything will be added, everything will have a pi over 2 in it. This is equal to sine A minus B. So now this will be more like, this is sine A minus B, this is cosine A minus B, because pi over 2 subtract the sine is also equal to the cosine. And this is cosine B, this is sine B, this is sine A, and this is cosine A, right? Because I'm just going to write it out. Cosine pi minus 2 minus A equals sine A, and sine pi over 2 minus A equal cosine A. Those are the two identities that we derived previously. So this is equal to sine A minus B. Now we can do the multiplication. So sine A minus B times 1 times 1, I'm just not going to write the times 1 down, is equal to sine A minus B times 1 plus cosine A minus B times 0 should be equal to sine of A sine of B plus cosine of A cosine of B. And there is something wrong with this. Let me see what's wrong with this. Okay, I think I figured out what went wrong. So this function right here is actually supposed, if I actually made everything go pi over 2, this has to also change. The direction of this has to change so that it goes on top. However, there's something that I can do that I didn't do, and if I change this, the only thing that I actually have to change is this. So this will stay as cosine B and sine B, right? Because if you think about it, if you remove this 90 degrees, you'll get a triangle like this, right? And then if you remove this 90 degrees, you'll get a triangle like this, and they're still congruent. They're really small sectors of the circle, they're still congruent. So it'll be sine A minus B is equal to, let's try again, sine A cosine B plus cosine A sine B. And there you go. That should be the answer. Now what about the tan? The tan is equal to the sine over the cosine. You guys already know that. So we can just plug in our sines, and we can plug in our cosines, and we would get the function. So this will be sine A minus B, which is our sine A cos B, cos A sine B, cos A sine B. And then this is over this is going to be over cosine A cosine B plus sine A sine B. This is a little bit tough, and the reason why this is a little bit tough, we can't we this looks like it doesn't look nice. It's not in terms of tan, and it doesn't look nice. So let's make it in terms of tan, and let's make it look nice. So this is equal to the same thing as we're gonna split it. So sine A cos B over this crap, cos A cos B sine A sine B. I don't think that'll help either. Cos A cos B sine A sine B, and cosine A plus sine B. Actually, I don't think any of those formulas are gonna help. So this is what you're gonna have to deal with the tan equation right now. However, I can tell you that the real tan A minus B equation is actually does actually simplify to this. So it would be tan A minus tan B over 1 plus tan A tan B. And how they got this was they did sine over cosine A minus sine over cosine B, which gets you sine A. This gets you sine A cosine B over cosine A cosine B, and this gets you minus sine B cosine A over cosine A cosine B, and then over tan A tan B, so that's sine A sine B over cosine A cosine B, and we want to add the 1, so we're just going to make the 1 in terms of cosine A cosine B as well, since everything is under cosine A cosine B. Let me see if that's even in the screen. Yes, cosine A cosine B over, and then this will be cosine A cosine B. So then if you simplify this, everything at the bottom simplifies on top like that, and then you'll have sine A cosine B minus sine B cosine A. And I think I did this wrong. I think I did this a little bit wrong. It's supposed to be minus, and I think I got the identity wrong as well. If you take pi over 2, you subtract. No, I didn't get the identity wrong. I don't know what happened. But sine A cosine B minus sine B cosine A over cosine A cosine B plus sine A sine B, and that's the answer. That's a very big amount, a lot of stuff to have in your mind, a lot of stuff to think about. So you should just use this function, or you should just use this function right here. Right, this function or this function is exactly the same thing. If you want to simplify it to sine cosine, you can use this function. But this function is a mess, so don't use it unless if you want to like hurt yourself. So we're going to evaluate the expression given that cosine A is 4/5 and sine B is minus 15 over 17. So what we can do in this case is we can just use all the identities that we've already been using. So sine A plus sine B, find sine A plus B is equal to sine A plus B. We haven't derived this yet, but it's pretty obvious to just write out sine A cosine B plus cosine A sine B, because the minus is minus, so the plus is plus. Right, and the plus is going to be sine A for the A minus B, it'll be sine A, it'll be sine A cosine B minus cosine A sine B. So this sine A plus B will be sine A. Actually, we don't have the values of sine A and sine B. I will find the values real quick. So here are the values of sine A and sine B. 0 to pi over 2 means it's going to be in the first quadrant, and the cosine is 4 over 5. So adjacent is 4, so this x is 4, and then our radius is 5. And this is cosine A, right? So this is A. So in order to find sine A, we have to use Pythagorean theorem. 5 squared minus 4 squared equals c squared. C equals 3. Well, b squared, b equals 3, right? Which will give you this is 3. And then sine A is 3 over 5. And then I'm going to use the same unit circle. This is really abusive, but I'm going to use the same unit circle. This is 3 pi over 2 to 2 pi. This means it's in the fourth quadrant, and it will be sine A, that's opposite over hypotenuse. So sine B is this is the 17, and then this is the 15. And then if you do 15 squared, 17 squared, well, I'm not going to do that, but I know that this is 8. So if I take this B angle right here, and then I do the process, B is equal to opposite, is equal to adjacent over hypotenuse, which is 8 over 17. So cosine B is 8 over 17. Okay, we figured out everything. So now we're just going to plug it into these formulas. Very simple. So sine A cosine B is 24 over 85. 24 over 85. And then add cosine A sine B. Cosine A sine B is minus 60 over 85. So minus 60 over 85, which gives you minus 36 over 85. Pretty nice. No, not nice at all. And then this A minus B will just be positive. So it'll be 84. So A minus B will be 84 over 85. Because this negative will turn positive. What about the cosines? So the cosines will be cosine A cosine B minus, well, first cosine A cosine B plus sine A sine B, and then we have cosine A cosine B minus sine A sine B, right? So cosine A cosine B plus sine A sine B. This is for the minus. No, this is for the minus. This is for cosine A minus B. And this is equal to cosine A cosine B 4/5 times 8 over 17, which is 32 over 85. And then this is sine A sine B, so sine A sine B, which is minus 45 over 85. So that is minus 13 over 85. And then notice that cosine A plus B is just equal to 32 plus 45 over 85, because it's changed its sign, which gives you 87 over 85. Very nice. What about tan? Well, you could use the tan formula for tan. You could use the tan formula for sine and cosine. But you already know what we're going to do. We are just going to use the sine and cosine. Not even the formulas, just this. We're just going to do this. Because this is a way easier way. If you already found the sine, if you have already found the sine and cosine, why do you even bother doing any of that? This is equal to, so the first is minus 36 and the second is 87. So it's minus 36 over 87. Finished. That's it. That's literally it for the whole thing. It's very simple. And then we have sine A minus B. over cosine of a minus b, which is, well, we have right here a minus b 84, and then no, this is actually, I'm sorry about this this mistake. It's 77. It's 77 over 85 because cosines can't be more than 1. So a minus b is 84, and then a cosine a minus b is minus 13. So it's 84 over minus 13. Finished. Done. Okay, this is the final question, and it's pretty complicated. Let's say for the least, and we will go and do. We're gonna go and do something that you have to have a really good understanding of the unit circle in order to be able to figure this out. So what is the slope of a line? I'm gonna draw a unit circle right now, right? And then I'm gonna draw a line. I'm gonna draw like these coordinate. I'm gonna draw a line, a ray. What's the slope of this ray? I'll give you a minute to think of it, and I'll give you, like, I don't know, 20 seconds. I'm gonna fill in stuff that might help you know. This is not sin x. That might help you know what the slope of the ray is. So okay, I think you guys have figured it out already. So the slope of the ray is sine x over cosine x, which is tan x. The slope of any of the lines that you have moving out is tan x. That's something that that's something that I've actually never known before until doing this question. The slope of any line that you've ever seen is tan x. So as long as you know the angle that it meets the x-axis, it's tan x. So basically, in this question, we're saying that m1, right? If you actually read the question, I didn't read the question for you. M1 is equal to tan theta 1, and M2 is equal to tan theta 2. So in order to make the equation, we can use a different formula. I'm gonna use a different formula. This is tan theta 1 over theta minus theta 2 is equal to tan theta 1 minus tan theta 2 over 1 plus tan theta 1 theta 2. I'll probably forget this the next lesson. Let's be really honest. You don't have to remember this formula. You can derive it from the sine and cosines. I recommend you remember the sine and cosine, but you can also derive it from the circles. So it really doesn't matter. This is equal to m1 minus m2 over 1 plus m1 m2. That's it. You only need the slopes. The y-intercepts are pretty irrelevant in this case. However, if you want to find the acute intersection of this line right here, we're going to plug in the slopes, obviously. So this m1 is just 1. This m2 is minus 1 over square root of 3 minus 2. This is not the nicest number. Divided by 1 plus, and then this is just going to be 1 over the square root of 3 minus 2, because it's the exact same thing. What we can do is we can try to collapse this by putting everything under square root of 3 minus 2, which is this is going to be, okay, I'm just going to remove the b, I'm sorry. So this is going to be square root of 3 minus 2 over square root of 3 minus 2, and this is going to be square root of 3 minus 2 over square root of 3 minus 2, same thing. And we can add them. So this gone, this is gone. Now we have square root of 3 minus 2 minus 1 is equal to square root of 3 minus 2 plus 1. And this is just going to be equal to square root of 3 minus 1 over square root of 3. Square root of 3 minus 3 over square root of 3 plus 1. And this is the answer, unless you want to rationalize the denominator and be not the best person ever. No, actually, this is minus 1. I'm sorry. So this is the answer of the tan, right? Is this the this is the answer of the tan. So in order for you to get the actual answer, you have to do tan inverse or arctan of square root of 3 minus 3 over square root of 3 minus 1. and you would get that to be roughly around, I'd say this is square root of 3 minus 3, so that's about minus, you get about, it's going to be a negative, so you'll get about 20 or 30 degrees. I don't bother actually finding the degree of the equation. So there you go. You'll get about minus 20, minus 30 degrees. So that's going to be it for today's episode of math. That's going to be it for today's math. And next time we will be learning about the laws of cosine and sine.